start with this one. Everyone ready? Okay, I want to introduce an effect. It's called heat island effect. Okay, so what does heat island effect mean? Heat island effect means the urban means city. Okay, urban means city. Rural, this means countryside. Okay, rural means countryside. 郊外 means countryside. Urban means city. So this so-called heat island effect means, or you might put urban here. Urban heat island effect. The urban heat island effect means the cities. Okay, the cities usually warmer. The temperature is higher. The temperature is higher in city. Okay, city usually warmer than the nearby rural area. Okay, I think you can experience this, right? When you go through the countryside, you can feel the cool breeze. Okay, so the urban heat island effect means, the cities are usually warmer than the nearby rural area. The reason is the city got lots of materials, okay, such as concrete. For example, like concrete. The area, for example, like concrete. 水泥 concrete. Okay, for example, like concrete. Concrete will absorb heat. Okay, so concrete. Okay, asphalt. 柏油路 asphalt. Concrete asphalt. Those materials will absorb heat, absorb more solar radiation during the day. Okay? However, they release heat slowly at night. Okay? Absorb more solar radiation during the daytime, but release heat slowly at night. Understand? Okay, that's the reason the rural area are cooler. Okay, you know, rural area with for example, like tree, like grass, like grass. So the surface of tree or grass, they will absorb less heat and provide the cooling. Okay? Even it will occur evapotranspiration. From plants. Okay, transpiration equal evaporation. Transpiration equal evaporations. Transpiration equal evaporations, but transpiration is for the plants. Okay, it's evaporating from the leaf. Okay, it's from the leaf, from the somatas of leaves. Okay, I'm gonna finish this one. Everyone okay with that? Okay, this is easy, okay? Okay, so I got another one, okay, another one to explain here. So this is what I'm talking about. The surface in the CT area, okay, absorb more heat. Absorb more heat. However, it will release absorb more heat during the daytime. Okay, but release heat slowly at night. But release heat slowly at night. In the rural areas, okay, wasn't those trees, those grass, the surface of those materials absorb less heat. So provide cooling. Okay? And plain transpirations. I just mentioned this, right? Transpiration equal evaporation, but transpiration is spatial term for plants. Okay, the water evaporates from the somata, 气孔. Okay, somata of the leaf. Okay, so next slides, I want to talk about the weather, the temperature inversions. So this slide is calling temperature inversion. The temperature inversion. Okay, the temperature inversion only occurs in the poor, in the day with poor air quality. Okay, and also with the calm winds. Calm winds mean the wind is very like breeze. Okay, it's calm breeze. No winds, almost no winds. Okay, what's a normal situation? Okay, let me draw a normal situation here. Okay, normal situation is the warm air. The warmer air goes up, right? The warmer air. And cooler air. This is normal situation. 正常的情况下 warmer air goes up, right? Warmer air goes up. Warmer air rises. The cooler air sinks. Okay, the cooler air sinks. This is normal situations. Okay. But the problem is, this warmer air come to here. This warmer air comes here and cover just like a lid. The warmer air raise, okay, and held the mixed pollutants upwards. Okay? So it's just like a lid. Just like a lid. Just like a lid. Guys. Just like a lid. Okay, warmer air goes up. So it becomes a lid. And cover it. Okay, so this becomes a lid. Okay, you can think about it. For example, like a hot pot, right? Okay, for example, you are cooking a hot pot or cooking a soup, right? And we just know warmer air goes up and cooler air comes down, right? So warmer goes up and the cooler comes down. And the warmer air just cover here. The warmer air just cover here just like a lid. Okay? So the cool air will come here. So you're gonna be the cooler, the warmer. Okay, the cold air, in this case, the cold air so in this case, the cold air will stays near the ground. Near the ground. Why we call this temperature inversion? Because normally, the higher the cooler. So in normal situations, normal temperature, let me call normal temperature. Normal temperature, the higher the cooler, the lower the warmer, right? If you go mountain climbing, right? If you go mountain climbing, you go higher, the weather is cooler, right? The lower the ground, okay, the weather is warmer. For example, you are wearing a t-shirt here, right? But if you go mountain climbing, you might need a snow coat, like that. So the normal temperature is the higher, the cooler, the lower, the warmer, right? But what happened to here? Because the warmer air goes up and like a lid and cover it, and cooler air comes down. The cooler air comes down and the cold air just stays near the ground. So the temperature becomes the warmer, the higher. Okay, the warmer, the higher. And the cooler, and the lower, the cooler. Student, do you understand? Normally, normal temperature, okay, the higher altitude, 海拔越高, the higher altitude, the temperature will be lower, right? The lower altitudes, the temperature is higher. But if the air quality is very bad, if air quality is very bad, with not much wind blowing, the warmer air goes up and like a lid and cover it. Okay, and like a lid and cover it. You can think about this as just a pot, right? And this is a lid. And the cold air will go to ground and stays there. Okay, the cold air will stay near the ground. So the temperature just inverts. The temperature just inverts. And it becomes the higher, the warmer, the lower, the cooler. If you understand what I'm talking about, please raise your hand. I'm sorry, let me use Mandarin to explain to Taiwanese students. 一般的气候是不是越高越冷，越低越热？可是这个因为它有污染的时候，它的 warmer air goes up， 变成了一个像锅盖这样子，然后冷空气往下，所以变成越往上面越温度越高，越下面越冷，所以才称为 temperature inversion，temperature 导致了。Okay? But it needs two conditions. First condition is poor air quality. Second condition is Second condition is calm winds. There's no much wind. Understand? Okay. So this slide tells us. Okay, this slide tells us the temperature inversions. Temperature divergence. So normally as this is normal situation. Normal situation, high increase, temperature decrease, right? Normal situations, temperature decrease with high, right? This is normal situation. For the temperature inversion, it's just opposite. As high increase, temperature increase. Understand? The reason is those pollutions mixed with warm air goes up and become a lid. Okay? Have you guys ever eat hot pots? For Indonesian student, hot pot, right? So if you eat hot pot, right, the hotter, the warmer fluid will goes up, right? The cooler, the warmer will goes up. The cooler, the colder, or the cooler will comes down, right? And this warmer becomes just like a liquid, carbon. Okay? Okay, today I'm going to talk about quite a few air pollution control device. So you can memorize this A, B, C, D, E. Sorry, we don't have F, V. Okay. First one is called absorption tower. Absorption tower. So absorption tower is good to remove. It's good for removing gases, pollutant. The first one is called absorption tower. Absorption tower is good for removing gases, pollutants. And the second one is called big house. Okay, big house. You got another name, it's called back filter. So it's like a vacuum, it's like a bat in your vacuum cleaner. Okay? So this one is good for removing dust particle. Like PM. So this is good for removing dust particle, the fine particles. Okay, so this one is just like a vacuum cleaner, the filter of vacuum cleaner. So this one is good for removing the fine, the smaller one. But if you have a bigger size, you have a bigger one, okay, then we should use this so-called cyclone separators. Okay, so this is good for removing larger particles. But keep this one in mind. This guy, the cyclone separator, is not good for removing small particles. Okay, it's only good for removing larger. For smaller particle, please use the big house. Okay? For fine, the fine here means small. Okay? The fine here means small, 不是好的意思。The fine here doesn't mean good. The fine here means small. Okay? So one is good. Maybe let me change it to this. Okay, maybe change it a little bit. Let me do the comparison. Okay. So the big house is good for removing smaller. Okay? That would be better. Okay? The big house is good for removing smaller. The cyclone is good for removing a larger. Okay, next one is absorption bag. Absorption gap. This is good for removing VOC. Normally with activated carbon. Normally we will put some activated carbon, 活性炭. Alright? I want to compare two words. Lots of students mix up with these two words. One is called absorption. The other one is AB, up. The other one is absorption. Can anyone, I don't know if you know about this, let me ask you. One is AB, absorption. The other one is absorption. Let me ask you that. Maybe, how about 平准? Do you know the difference between these two words?
吸收跟吸附，一个是气体到液体里面，然后吸附是指说气体或液体在固体表面上。
Can you use English? Try it. Try it. Explain to everyone in English.
Absorption, which is meaning that.
Yeah, I think your English is very good. Don't be shy.
Gas to liquid phase. And what about absorptions mean liquid or gas on a solid phase?
Very good. So absorption means the pollutant enters a liquid. Okay, absorption means the pollution entered from the chemical engineering aspect. Okay, from the chemical engineering aspect, absorption means the pollutant enter a liquid. Okay. However, at AD, absorption means the pollutant sticks to a solid. So one is liquid, the other one is solid surface. Understand? So I hope you can differentiate these two words. Okay, from the engineering aspect, especially chemical engineering aspect. Okay, please write this two down. Okay, next one is electrostatic. Precipitator. Okay, so this is good for removing particles, smoke, even ash. And last one is called Venturi scrubbers. Okay, you might learn this in unit operation, right? I don't know if you learned this before in unit operations. So this is good for small particles and also soluble gases. Good for small particles and soluble gases. Okay? Everyone okay? And I found this from not in our textbook. Okay, I found this in another textbook. I found this pretty good. So this is depends on different size. Okay, you can choose your air pollution control device based on different sizes of particles. Okay, for example, like if the size is very big, right? The size is very big, please use cyclone. Right? If the particle size is very big, please use cyclone. Okay? But cyclone, as I just mentioned, cyclone is not good for smaller particles, right? So for the smaller particle, you should use, for example, like a bag. Okay, bag filters. Okay, equals big house. Okay, you can even use the electrostatic precipitator. Understand? Okay. Let's start with absorption towel. Okay? So absorption towel also named this. Absorption towel also named this. Pad bags, spray towel, wet scrubber, or even gas scrubber. Okay, so it's good for remove like sulfur dioxide, HCl, NH3, CO2, and VOC. Okay, if you want to remove like sodium or sulfur dioxide, okay, if you want to remove sulfur dioxide, hydrogen chlorides, okay, ammonia chlorides, and VOC, please use absorption towel. Okay, so first step is so-called diffusion. Okay, as just like Ping mentioned, right? So those pollutant gas will will attach to the surface of liquid, not solid. liquid, not solid, right? At AD is solid, AB is liquid. Okay, so second step is called transfer. Okay, so you're gonna cross the gas-liquid interface. We also call this dissolution. Dissolution. Okay, and last step is also called diffusion as well. Okay, so those dissolved gas. Okay, diffusion of dissolved gas away from the interface into the liquid. Okay, so when gases introduced come to your mind, you might think about what? You might think about Henry's law. Okay, you might think about Henry's law. Right? Okay? So we learned this previously, right? Okay, so okay? Okay, as I mentioned, absorption towel also known as the pet bag, okay, spray towel or web scrubber. So it looks like this. So it looks like this. Okay, so the contaminant gas will enter. The contaminant gas will enter from the bottom of air. Okay? So the contaminant gas enters. Okay? And the liquid reagent will contact. So inside the liquid reagent will contact the gas. The pollutant will transfer. The pollutant will transfer from the gas phase. Okay, the pollutant will transfer from the gas phase into the liquid phase. Then we have a packing here. Okay, and we have a packing here. The reason we have a packing material here is they're gonna provide the larger surface area. Okay, some advantage that we have packing here. The packing material first, okay, will increase surface area. Okay? So, help the gas and liquid contact. More efficient, more effective. Okay, the packing materials, the advantage of packing material is first, it can increase the surface area, contact surface area. Okay. So in light of this, it will help the gas and liquid contact more effective. And here we got one thing called mixed elimination. Okay, the mixed elimination match test is helpful to remove water droplet. Okay. Because some water droplet will carry some chemical with chemicals. Okay, some water droplet will carry chemicals. So the last step, we need a mixed elimination match. Okay, this gonna help us. Okay, this gonna help us to remove water droplet with chemicals. Then after that, we can have the clean air to go. Okay, so this is the PET towel, PET towel one, right? Everyone okay? Okay, so in our textbook also shows us the plate towel, okay? The plate towel. Okay, let's do these questions. A mass balance diagrams of counter current flow absorption. So this question is from textbook. Okay, this question is from our textbook. Okay, in our final exam, I'm gonna put 60 to 70%. I'm gonna weight 60 to 70% from our textbook. Okay, so if you don't have textbook, you need to borrow one. Or you need to find the electronic versions. Okay? 60 to 70% will come from our textbook. Okay? And 30 to 40%. 30 to 40% were based on my course notes and what I mentioned in the class. For example, I might ask this. So if you don't listen, you don't take notes, okay, you don't know how to answer. Understand? Okay, let's do these questions. Okay, so this is mass balance diagrams of counter current flow absorption. This is absorption column, right? And this is mass balance equations. The mass balance equation is here. Okay, let's take a short break. Breeze 3 over this. Okay, breeze 3 over this. So let's break. So it's 2:10 to 2:20. Let's break until 2:20. Let's come back 2:20. Stop. 这次外面电了，再去逛外面。
抽筋吗？
还有今天你们没有跟我乘，今天超慢的，没电了，都没有声音。
你还要开小
再换一次。